Hello, Programming 12. We are having fun, or at least I'm having fun. I hope you are too, making this 3D environment, walking around. Now we're going to make it so we can bump into these walls we've created. Excuse me. So, as is right now, if you try to go into a wall, you literally go into a wall. You can explore the inside of these cubes, which is kind of interesting. But, not usually how video games work. You don't tend to be a ghost. Although maybe that's the next great Call of Duty game. Call of Duty Ghost Recon. Wait, that's the wrong franchise. But anyway, we are going to make it so we collide with walls. So we aren't ghosts. I think that will be a good way to do it. So what we're going to do is we are going to take that dot. See that red dot? We're actually not going to use the exact red dot. But we'll use a point that's in that direction, and we're going to convert that dot into a coordinate in our two-dimensional map, the PNG, the image. And we'll check to see if it's a white pixel or a non-white pixel. When we convert that number, if it turns into a white pixel, then we're not running into anything. If it turns into a black pixel, we're about to run into something, so stop. This is similar to how we are doing the chess game. Remember the chess game? We took our mouse coordinates and we divided by grid size. Then we could figure out what piece it was in the 2D array. Same idea, except our 2D array is a image. So we can draw on it and edit it. So that's the story there. This isn't going to be a long lesson, but there's definitely some tricky bits. So time-wise, it might be fairly long as I explain it, but the amount of code we're going to add is fairly small. I'll also leave you with some things to do and work on as well. So I'm going to pull out of this. Oh, hello. I'm looking at myself. That's not what I wanted. So here I am in my project. I'm in the move method. And in the move method, we have our keys that are controlling movement, of course. And so I want to only do this movement if I'm not going to bump into a wall. So I'm going to make a new function called something like can move forward or something like that. So I want to write it like this. So if I'm pressing the W key and can move forward returns true. What is can move forward? Can move forward is just going to be a Boolean method. Or a Boolean function, I should say. It needs to be a Boolean as opposed to a void function because it needs to return true. You can't be inside of an if statement if it doesn't turn into true or false. So I'm going to make a function down below underneath my move function. It's getting pretty crowded in here. I'm thinking I might want to make a move tab and put all my movement stuff. Gosh, got to go down, down, down. So here I am at the end. This is going to be Boolean can move forward. And eventually, at some point, I'm going to have to return true or false. Return true or return false is how this is answered. So I'm going to do some math. I'm going to decide, can I move forward? Should I be able to move forward? And I will answer that by returning true if I can and false if I can't. So here we go. So the first step is to figure out where are we about to move to. So we need to calculate the point in the direction we're moving. No problem. We already do that, right? We already have that math. That's our focus, X, focus, Y, focus Z in our camera, right? That's this math right here. This is in the move function. I'm back in the move function again. 300 is a bit far away. If we use 300, we'll collide a little prematurely. We'll just kind of like hit before we really looks like we should. So I'm going to use basically the same math to calculate some new points, but I'm not going to project it 300 pixels into the distance. Something like 150 or 200. I don't know what the right number is, but I'll do something like that. But effectively, this is the right math here. So I'll recalculate that. And I'm going to calculate it. I'm going to make the variables here in the Boolean function. They don't need to be anywhere else. No other function needs to look at these numbers. It's all encapsulated. It's all sealed up inside of this function. And then I don't have to get my global variable space so messy with so many variables. So I'm going to make float. And what should I call it? Like forward X, forward Y, and forward Z. I mean, forward Y is really easy. That's just going to be the same height. We're not going to be looking up and down. Like looking up doesn't make you collide with the ceiling, so we're just going to keep that at the current height. But x and z will be turned into the x and y coordinates of our map in the PNG, the little picture that we drew. So we'll use those for sure. So I'm going to bring over this math for the x. So I'm going to say forward x equals that. But I don't think 300 is good. I'll leave you to decide what would be a better number. Maybe 200, maybe 150. Your call on that. You decide what would be the best number. I'll put 200 to be on the safe side a little bit. Not too sure what would be best. Somewhere between 200 and 100 though. I think 100 is too short. So for forward Z, it's going to be that. So it's projecting from the camera location along the angle that we're facing. That's this angle here. And then again, I'll keep these consistent. It would be silly to make them different. That wouldn't work out too well. And then what about forward Y? Forward Y is not going to be any different than IY. That's not going to change at all. So I'll just leave that to be the same. You might be wondering, why don't I use tan? Like in my movement code, I use tan. But I'm not going to collide. When I look up to the ceiling, I'm not going to collide with the ceiling. I'm looking to see if my body is going to run into something. And my body is at IY level. So that's the reason why. My head turning does not make me collide more likely with things. Turning up. Turning left and right is not my head turning, it's my body turning in this game. So that's important. So that's the story. So once we have these numbers, we can then do some division. There's another complication, though. It's another complication. Do you remember how when we first drew our map, it was locked into 0, 0 as the corner, and then we had to do this math here. Let me show you. It's in draw map. Draw map. Sorry, one moment. Draw map is here. Yeah, we had to do this map here, minus 2,000. Minus 2,000. And the reason we did that is because the map starts at 0, 0 in the image. The image starts at 0, 0. But in our space, we were starting at negative 2,000, negative 2,000. I'm kind of regretting putting it at negative 2,000, negative 2,000 now that I think about it. Because now I got to convert that when I go back to my map. I think it's easier just to convert at this point, but in hindsight, I wonder if I made the right choice. So let's go and convert, because I think it's really easy to convert. All I have to do is undo that minus 2,000 by adding 2,000. And then I can divide by grid size to find out the coordinate in the map that corresponds to the location of this this forward X, forward Z type of things. So let's do that. So I'm gonna make a new int variable. I don't know. I think I will. Yeah, I think I will. So I'm gonna make this variable. This is gonna represent the coordinate inside of the map. So I'm going to say, maybe I'll put this up here. Put this up here. Int map x and map y. Those are going to be the coordinates of the map that correspond to my 3D position. So to do that, I'm going to say map x is going to be connected to forward x, but we have to subtract 2,000 from it. And then we have to divide it by grid size. However, it's a float right now, and I want to get an int answer. I want to get a pixel number, right? 0, 1, 2, 3. And if I leave it as a float, I'll get a decimal answer. And there's no such thing as like a fraction of a pixel. You can't have half a pixel or a quarter of a pixel or whatever. So I'm going to make this an int. This calculation, I'm going to turn into an int. I could subtract the 2,000 on the inside or the outside, but I'll do it on the inside. And then I'm going to divide by grid size. So same calculation as how we did it in the chess project to turn a mouse coordinate into a grid coordinate in your 2D array. And then map y is going to be the same idea, but with forward z, because our xz plane is the floor. And so we're converting that to a floor plan. Oh, sorry, it's not minus. It's not minus, it's plus. Plus. It's important because we're undoing the previous subtract 2,000. Hope that was clear. So make a note of that. We're adding 2,000, not subtracting. My bad on that. Okay, so now that we have that information, we can go and see what is the color there. So if map.get map x map y equals white, that means empty space, then I will return true. The answer is yes, I can move because there's nothing there. On my floor plan, I haven't gotten to a wall yet. And else, return false. And I'll make that slide up a bit. So there you go. That's my function. And this is a fine function. Can move forward, works. I think we'll see. Let's go try it. I'll run it, and we'll see if we run into things. Because that's 200 and not 300, the ball, that little red circle, won't quite... oh, my mouse is... there I am. My mouse... it will not quite be exactly where it is. It'll sink into the wall before I do. So it'll disappear when I hit, but let's see, do I hit? Ah, I hit. 200 is pretty good, hey? That looks like maybe the wall. So that's looking pretty good. If I move over here, I'll go collide with this one. Does that work? Yes, reasonably well. So, we are getting things working roughly. But here's some things like that. Oh, that's nice. Oops, there's good. Whoa, too much. I hit it. Oh. So, it's working pretty well. But here's where it doesn't work. Watch this, watch this. If I see how the red circle is slightly off the wall, it's not quite on the wall. If I move forward, it will miss, and I will go through the wall. I will cut it. You can get pretty tight. You'll just miss it. Just misses it. Obviously, not how video games actually do it, right? Like you should detect this collision here as well. Oh no, didn't quite work. I was just slightly off. If I'm just slightly on, it's fine. I can't. My mouse control. I don't actually have a mouse right now. I'm using the trackpad. It's not great. Like if I'm just slightly on, it's fine. But any slightly off is bad. So not good. Also, left and right, I can still no problem walk left and right through a wall. I can also go backwards through a wall. So I can back right through a wall, back into outer space. That's fine. Notice that once I'm out of the map, I can't move forward at all because that no longer is a point in our map. So I'm out of bounds in our map. I'll try and steer backwards into my world. There we go. Kind of a weird thing to do. Okay, so that leaves us with some work for you to do. So that's how you do it in general, but you'll have to project some. You have to project some points in different directions as well. So one thing you can do with that is you can make two collision points that are slightly to the left, maybe like 20 degrees to the left and 20 degrees to the right. And as you're moving forward, make sure that they are also not colliding with any grid points. You can just make some new variables. Forward x and forward z could be left x, left z, right x, right z. And when you do those calculations, you could just add 20 degrees to this angle. You could do radians 20, for example. So you can make a new set of calculations and project points to the left and right to make it less likely that you'll collide in an awkward space. And then when you're strafing left and right, that'll be another function, another Boolean function, maybe can move left, can move right. Two more Boolean functions that decide, are you able to go that direction? And you would project 90 degrees to this angle, plus or minus, to see if you can go there. Same kind of math, but you need to project the point in the right direction. Same with going backwards as well. If you go backwards, you need to be able to see like 180 degrees from this point. Project backwards to see, is there a wall behind you? So it's all about the angle, and see if you can manipulate that angle to get correct points. I would say you're going to need this for sure. You're going to run Boolean can move left, Boolean can move right, and Boolean can move backward, or whatever you want to call them. Each one will calculate these same kind of things. Also make, this move forward more robust. Don't let it cut corners. do a forward left X, which is just like 20 degrees to the left. Just make a left and a right set of coordinates. Left Y, left Z, make a right X, right Y, right Z. And make those recalculate those, but like 20 degrees plus or minus to your direction. I don't know if 20 is the right number, by the way, so please let me know if 20 works and if you need to go further out or closer in. That's up to you to decide. You might need to do something similar for the move left right. I'll let you take a look and see. I think you probably will if you want to get it really sharp. So make all these changes for all the different cardinal directions you need to move in. That's not a small amount of work. So it's pretty formulaic, but I find formulaic things are easy to screw up if you mess the formula up. So thanks so much for your efforts in here. I hope you have a wonderful day programming. We'll see you next week. I won't see you. You'll still be remote, but I'll see you on Teams for sure. Okay? Hey, thanks so much, Programming 12. Have a great day.